Hey everybody, I'm Jan, and today I'm going to be presenting the topic of optimizing token-based systems with risk data science. I work at Analitica and MakerDAO. You're most likely familiar with MakerDAO. For those that are not, they are the largest stablecoin provider at the moment with DAI, which based on supply. And Analitica is an R&D company that specializes in DeFi economic risk intelligence. We've been collaborating with various DeFi protocols. Some of the well-known among those are MakerDAO, Compound Aave, and Ajna. And at MakerDAO, we are responsible for managing economic risk of decentralized collateral. The outline of the talk, first I'm going to motivate both risk data science and also how it intersects with economic risk in token-based systems in general. And then I will go on to presenting the economic risk, especially as it pertains to the DeFi ecosystem. I will continue with an overview of different data science methodologies and how they can be applied to token systems. And then I will provide the first case study at MakerDAO of our own work, and I'll continue providing some other examples beyond the DeFi. That means just, let's say, different L1 protocols and so on. And finally, I'm just going to summarize some of the insights from the talk. So token-based systems tend to optimize for multiple system goals, and these are not only pursued simultaneously, they're also pursued most often one at the exclusion of the other. They're also complex systems, so that means that it's very difficult to isolate individual components, ignoring one altogether. So that means that these goals can be basically characterized in many ways. One of them is in decentralization, growth, revenue, and robustness. And whereas revenue and growth are much easier to quantify, we have robustness, which is a more hidden property of the system, and it's not only hidden, it's also very dynamic, which means that we need to monitor it also over time. And sometimes it's just sometimes projects are just, as we've seen in the past, they're just very high-flying catastrophes just waiting to blow up. And then we have also decentralization, which is clearly a key value in the ecosystem, and it also provides very importantly to robustness. Then we have our own work, which means just focusing on both the qualitative and also quantitative aspects. But in this case, we're going to talk about more the quantitative ones. We have the visualization on the slide, where we show this kind of nice trade-off space between different system goals. And in the visualization inside, we can see how basically by moving in the space, we prioritize one goal over the other. And when it comes to just the motivation behind all this, it has to do with trust. And while it might seem paradoxical talking about trust and trusted systems, it has to do with minimizing the trust assumptions, basically the number of governance decisions and so on, meaning moving from manual human decision making towards more autonomous decisions. And that's how basically robustness and trust come into play. Then we have the economic risk domain. As Trent basically mentioned before, there's been many hacks in the industry in the last couple of years, and the security audits are an obvious, let's say, attack vector when it comes to DeFi protocols. But then there's also the incentive design verification, which is not nearly as much addressed in different teams. And especially in DeFi, the question is often how can we maximize the capital efficiency at a given risk tolerance? And the key lever for this are usually different risk parameters in the protocols. And this is also important because, again, we need to monitor this over time because the market changes and we need to adjust these parameters dynamically over time. While this is not mutually exclusive at all, losses can come either from exogenous factors, that means the market, either volatility or liquidity, or then we also have different attack vectors, basically economic exploits. And one of the ways, let's say, is that if a certain token is highly liquid, we can pump up their price artificially and just borrow massive amount against it, and through that make money at the expense of some protocol economics. And at the same time, as the ecosystem progresses, we've seen also increasingly powerful risk mitigation features. One of them is granular optimization in the recently launched Aave v3 with E-mode and oscillation mode. And we come again back to the importance of asking what if questions and explore this parameter space. Data science methodology is basically a methodological toolkit that can enable us to study behavioral patterns to optimize token-based systems, and this can be either done before the launch and also after the launch. Before the launch, let's say it's often very important, as it was mentioned before, simulating system mechanics with different scenario modeling. That means testing also the user assumptions, the user behavior assumptions, and also the market dynamics. And then we also have the empirical analysis, which is extremely important to inform the potential improvements of the protocol, both on the design side and also on the parameter proposal. And finally, it's very important that we can also learn from the Web2 space, because they've been using data science methodologies for a long time, and we can transfer a lot of their knowledge also into our space. Moving on to just going quickly through some branches in the data science methodology. The most traditional one against these, in this case, is supervised, semi-supervised, and unsupervised machine learning. And this basically means that we need certain historical data, and we feed a model against it, and then we can predict certain value in the case of supervised machine learning. That means categorical or numerical, and in the unsupervised, we're trying to find some hidden behavioral patterns there. And I will also present a case study of our own work in this direction. Then we have simulation modeling and agent-based modeling. The previous talk basically focused a lot in this area. And the idea is, again, that we're stress testing the systems that we're trying to optimize, and with that make better decisions. Then we have causal inference. Because of the lack of, let's say, experimental approach, because of the lack of experimental approaches in token-based systems, both because of the technical limitations and also, let's say, the core ethos of credible neutrality, we don't have this kind of privilege of doing A/B testing as we do in Web 2. And for that reason, we need to have different approaches, and basic causal analysis is one of those, but we haven't seen much in this direction yet. Then we have graph analysis, which is clearly a very nice mapping to blockchains, because blockchains can be modeled very nicely as basically entities, nodes, and interactions between these nodes. And then we have also the recently very hyped LLMs, the large language models, and autonomous economic agents. And these basically bring the best of both Web 2, that means the off-chain compute, and also Web 3, the smart contract automated actions. And an example of this is, let's say, that we would build an autonomous agent that dynamically adjusts the parameters in the system. And with that, we can have a much more transparency on how the systems operate. And finally, I just presented, I basically just listed here exploratory data analysis, stating basically that despite this being the simplest of those, of all these, it also builds on top of, it's a fundamental foundation for everything else, and at the same time, very often it provides the most value. Then we have our use case at MakerDAO. Basically, we are aiming to map surface insights of our monitoring systems, and that provide some on-chain proposals or decisions. That includes both the tools, that means software, different dashboards and different simulation models, all the way to processes, that means continuous research processes that we're optimizing, all the way to the action items. And most of our work is related to proposing risk parameters, but often it also includes, let's say, different smart contract modules that we're providing consultancy for. And the aim of all of this is to increase systemic robustness of MakerDAO. This is our first product, and this is also publicly available, so anyone can just open it up and look at the current state of the MakerDAO system. On the right side, we have capital risk metric, which is under the hood a simulation model that estimates the portfolio, basically the estimated loss of the portfolio given a certain market shock that we're simulating. And as we see over time this as evolving, we can notice, let's say, if there's a spike in the model, we can basically see what's the reason behind it. And let's say if there's a certain collateral asset that drops in value very rapidly, that's something that can inform this kind of decisions. But at the same time, most importantly, is parameters such as liquidity. So that means if the liquidity drops in a certain asset, that can provide more simulated loss of the system, and then we can also adjust the risk parameters based on that. And then on the other side, on the left, we have depth at risk, which is a simpler analysis, but the idea behind it is that we have this in the vault, like in the position, we have the collateral and the depth. And if we simulate the decrease in the price of the collateral, we can then also get a good idea how much depth can be liquidatable if none of the users would basically react, right? And that's also split by different risk scores, all the way from low risk, medium risk, and high risk. And that takes into account both the current state of the vaults and also their historical behavior. This is the second product and last product that I'm going to mention. But yeah, the last example was about simulation modeling. This is about supervised machine learning. And what we do basically is that we take into account all the wallets that currently have an open vault at Maker, and then we predict a certain number that determines what is the riskiness of this wallet, right? Taking into account all the vaults. And the credit grade basically goes from 1 to 10, 1 being very high risk, 10 being very low risk, and then we also have a nice portfolio view of the whole portfolio, which means that in this case we can see that most of the wallets have a very high grade, a very high credit grade, which just reflects the current state of the MakerDAO system, which is highly over-collateralized. So that means that I said that for each of the DAI that is minted, we have a massive, a large amount of collateral that backs it. And because we care about transparency and explainability for each of these predictions, we also have a factor contribution, or basically feature in machine learning lingo. And we basically just go through different features here. Let's say one of them is how much the price could drop without the wallet's vault would not be liquidated, then external capital of the wallet, and let's say also whether they're using third-party automated position management solutions such as DeFi Saver and Oasis. So these are two examples. And because risk data science doesn't just it's not just limited to DeFi. It's basically it can be expanded into token-based systems in general. I'm going to also provide two different examples that go into that of other teams in the ecosystem. I will go through gas gentrification of the Filecoin economy, Sybil attacks on Gitcoin grants, and also market manipulation through wash trading of NFTs. So first, Filecoin Economy, for those that don't know, it's a decentralized storage network where the storage providers basically provide the essential services to maintain the operations of the ecosystem. And then basically the Filecoin Foundation launched the Filecoin virtual machine, which enabled user programmable smart contracts. And the idea was that for the storage providers to provide their services, their operations need to be profitable. And there was this unknown dynamic of how much demand for the computer resources would actually come from the FVM. Because if there is too much demand from the FVM, we can basically come to a point where it wouldn't be profitable for the storage providers to provide their services, and that would obviously cause a problem to the ecosystem, and that's the case of gas gentrification. And the team basically did a deep dive into this dynamic before the launch and also after the launch, and they modeled this demand dynamics for the gas economy over time. And then also after the launch, they provided a nice example of of analysis where they showed that at the moment there is not much risk of the gas gentrification. And at the same time, they also showed that there is also a really good case of risk mitigation strategy where they would separate gas lanes, and by that the storage providers would always have a certain minimum amount of block space for them to continue doing their operations. Then we have Sybil attacks. Gitcoin grants, the aim of Gitcoin grants is essentially to provide a credible, neutral way of public goods funding in the Ethereum ecosystem, and they do that with the mechanism of quadratic funding. And because of the quadratic funding, they want to basically approximate the preference of the community for the donating to different projects as closely as possible. But that introduces the attack vector of Sybil attacks, where one entity spreads their funds across multiple wallets. And then we come to the question of how to define, how to detect, and also how to sanction this kind of behavior. That's when basically Gitcoin DAO with block science came to the stepped up, and they built the fraud detection and defense working group, and they focused on building this kind of semi-autonomous Sybil detection at scale. And what they managed to do in the end is to prevent more than 3 million in fraud with this. And this is an example of semi-supervised machine learning approach, where there is a human in the loop that basically does the sanctioning, whether a certain grant or wallet or set of wallets is basically fraudulent. Finally, there is the case of NFT wash trading. The basic problem with this is obviously that it really damages the reputation and the credibility of the ecosystem, because there's just a lot of trading volume that is faked, a lot of artificially inflated prices, a lot of just astroturfing and so on. So that's why it matters a lot that we're able to detect this and also mitigate against it by taking into account also, let's say, the way we design incentives. And we can see, just based on the different actors that studied this dynamic, from basically like pseudonymous crypto analysts to Chainalysis, which is a blockchain analytics company, all the way to a Big Four company. This can show the extent to which there is an interest in this kind of problem. And some of the insights are, let's say, that pretty much 40% of all NFT trades are faked. Then for some of the exchanges, up to 95% of basically trading volume is also flagged as suspicious. And then in the end also, let's say, it's sometimes a very highly profitable opportunity for traders. Let's say for Chainalysis, I think that showed that for the 110 profitable traders, they made more than 8.9 million. So that's, not all the traders are profitable, but just because of the potential profitability, there's a lot of this kind of fraudulent behavior. And with the approach of graph analysis, or just, let's say, similar approach as what was done by the FDD team, this can also be very nicely mitigated. Finally, in this talk, I wanted to talk about the importance of verifying the incentive design, and also how this ties when it comes to economic risk management, that improves the robustness of the systems that we're studying. And data science as a methodological toolkit can be a very powerful addition to this to uncover insights and optimize decision making, either on the design and also on the optimization level. And also, these examples are not just specific to risk. There's a huge intersection between risk, fraud, and growth. That's why it matters a lot that we are not trying to isolate these problems, but we need to look at them more holistically. And that also provides a case for the need of risk mitigation in token-based systems.
All right, thank you so much, Jan. 2 or 3 minutes left for questions. Do you guys have any questions? Total mental overload? Yeah. Can we have a mic here?
Hello. My question is the following. So how are you incentivizing your users to go beyond the data that you are providing them? So do you have a kind of platform where the risk analyst can, I would say, go beyond the nice dashboard that you have presented?
I mean, first of all, like all of this data is kind of open, right? Like just in general, across different platforms. Also, like some of our models are also open source, so they can be validated, right? And in general, like we also providing APIs for let's say for the maker specific data, right? So the people also have access to that for them to do their own analysis if they want to.
I see I'm asking this is because I am managing a data platform for my own DAO, and often the issue that I am meeting is that there is a skill set difference between data scientists and risk analysts, and often you need to provide tools that are aligning both, so they can actually query on a simpler way, maybe using SQL or getting the data directly in Excel, whatever. Do you have similar issues on Maker?
The way we approach it is that, let's say, our team is spread across developers, data scientists, and risk analysts. So there's a lot of just interaction, let's say, between this, because let's say risk analysts provide a lot of interesting insights, that can be consumed by data scientists, and then we, let's say, dive deeper into that, right? Or let's say developers automate certain research that we build, right? So there is always this interaction between different, let's say, teams in our company. And that's how we basically maximize our impact as well.
Thank you. And just last follow-up question, just out of curiosity, how many people are involved between risk and analysis in MakerDAO?
I mean, in MakerDAO, or basically like Block Analytica, there's about 15 of us.
Thanks a lot.
Welcome.
Okay, thank you so much again, Jan, for sharing your insights. And we'll have a final talk on the topic of token optimization and design with Rohan, talking about LLMs applied in the token engineering context.